Okay, Paul here, and today on the bench I have this Universal Waffle Iron that a customer sent in. Wanted to know if I can take a look at it and see what's going on with it. It's a model 15 UG17, 1100 watts, voltage rating of 110 to 120, made in USA, from New Britain, Connecticut. And we're going to see if we can figure out what's happening with it. I took the waffle iron inserts out. And these guys here, so we could get inside and see what was going on. So first thing we're going to do is check for continuity. Let me go ahead and put a couple clips on the probe here. I already see we have a few places where it got hot. I will leave that right there. Okay, move this over here. Hopefully you can see that. Let me adjust the camera just a little. And we'll just connect that. Well, for right now, we'll check the coils. Connect that there. Put this across here, connect it here. Well, let's get this meter going on ohms here. We'll move this over. Okay, and we'll connect this on the coil here. Maybe we will, maybe we won't. No, we did. And we got 7.2 ohms, 7.1 ohms. So that coil says it's fine. Of course, now we're measuring the two coils in parallel. This one got hot here, obviously. Let's just see if we still have the same thing here. 6.8. So I don't see any breaks in the coil. It did get hot here, but that's normal. These things get hot. So it's not the coil. But I see this here is very suspicious looking. This whole control assembly. It looks like it's stuck on. We're going to take that guy out. There's a contact there that screws up and down when you screw this in. That's off. And that's supposed to turn that on. It could be that the points in there are sticking. No, they don't seem to be sticking. Okay, let's see. It's going to get hot. This has definitely got hot here at one time. This whole thing is all rusty here. I'll have to clean that off, and I don't imagine that's making very good connection there. But we'll deal with that after. So this wire goes over to here, comes up through this coil, goes through this coil, comes down, goes through this coil, or this way, comes down through here, back over to here, and that's on the switch. So if we can measure across this entire thing here, that would be good. Let's try that. I'm going to try to get this. Well, I'm just going to put this on here. Set this to continuity. And you'll be able to hear the tone even though you might not see the meter. Okay, so if I touch that, we got continuity. Alright, now let's see if we got anything. Okay, we get a signal there. Let's turn it on high. Okay, we got a signal there. And that should be changing the resistance here a little bit. See if I can get clipped on that. I don't have to hold it because it's hard to know if the changes are my fingers moving around or the actual change in resistance from the probe being on there. So we'll connect this on here. Now I don't have to hold it. We got 0.7 ohms. As I go to high, as I go toward off. All right, I'm on 2 and I've got nothing. So I should have still something at 2, and at 1 I should have something. I don't have nothing at 1 or 2. And so, and the numbers are on the control here. So 1, 2, and off are doing the same thing. 3, it starts working. 4, 5, 6. So the switch is working above 3. So let's take this off, and we'll take this switch off gently. Okay, and we got a screw here that holds it inside. Get a screwdriver that'll actually do something. Okay, hold on a that. Let's see what we got. Okay, that's got to come out. That goes into that section there. Okay, we got to get that screw out. I was afraid of this sucker got really hot. Geez. I don't know how I'll be able to get that out of there. That's the screw in here, and you see how hot it's gotten. It's fried it in there. And this connector here is definitely, with this asbestos, is definitely a problem. And that ain't gonna come off either, it got fried. So, okay, the next thing we're going to check on this is the cord itself. We know that the coil's working, although the switch down here is not working correctly anyway. So we'll put the probes across the line cord and see what we got here for resistance. And what we have is a mess, 93K. We should only have 10-20 ohms because it's right across the coil. Hold on, let me flip it upside down and see if the switch is making any difference in that. So we turn this and watch that. And no. And we get 100K. It's making a little bit of difference, but it's still way off. There's something wrong with the cord. So let's take the cord out and see what we got here. Aha, we found the problem, and it's not a good problem. What is that? Oh geez, look at that. That's what's left of the connector that was on the end of the wire. Oh gee, the whole wire burnt off. This connector was on the end of this wire where it connects to this part of the element, and this one burnt off too. what happened was, because that switch is not working, somehow or other this thing stayed on, and it stayed on so long and got so hot of current flow. It's amazing it didn't burn up the elements. It actually melted the connectors right off. And imagine you can see where it got so hot that it actually blistered the Bakelite when it melted them. And there you can see the burn spots. So that's what happened. The cord totally burnt off the connectors. The problem is twofold. One, if I can connect the cord back to these wires where they're not going to have high resistance because they got so hot, just like the control inside. The problem is we still have the issue with the control. It will work, but its heat sensitive components may not work. In which case you can turn it on and set it and it'll be on and get hotter and hotter and hotter, and use the full 1100 watts or more, cooking all of the time. That's one possibility, in which case cooking waffles would be difficult because you would have to unplug it when the waffles are done. So it wouldn't automatically shut down when it got too hot. And you can see the wires got way too hot. So the other option, the other problem that could happen, which would be better, would be the control would still work the way it is working under ohms, which would mean that when the elements got really hot, the control should open and the system shut off. That's unlikely, or it would never have done this in the first place. There's no way to get this control out. I can't even get that screw out. It's so corroded in there, it got so hot that it's just not going to let go. There's no changing this control, and there's no finding another control. What I would suggest is, until we find a control, which eventually one of these will come available, but it may be a while. Till we find a control, we can't change the control. I could try to connect these wires. That's going to be difficult because the connections are fried. It's not like I can solder on that. I can't even solder the wires to that. They're not going to solder. But let's assume that I can get wires on here and get this connected. And this is just a royal mess. But let's assume that I can. What you're going to end up with is a toaster. What the customer is going to end up with is a toaster that would have to be unplugged all of the time, a waffle iron. You could plug it in, possibly make waffles, and then you'll have to unplug it. The switch, the offsetting on the switch, which is in here somewhere, this offsetting on the switch is not going to work. It's just not going to do it. It's not going to shut it off. 1, 2, and 3, 1 and 2 for sure, maybe 3 may not even work. But when it's on 4, 5, and 6, and 7, or high, once it gets hot, 1, 2, and 3 and off may no longer shut it off. They may keep it on, and that may be what happened to this. So it would have to be unplugged in order to stop it from using heat. There's no way to be on. So you have to unplug the cord. That would be the only way to make absolutely sure you got it shut off. If the owner wants me to try to do that, try to connect this cord up to here, and of course I'd clean the unit a little bit so that it'd be safe. But if the owner wants me to connect the cord up to this control, I can try that, but there's no guarantee that the wires are going to stay on. They may not. And added to that, they may not make good enough connections. Here's a piece of insulation in there. Contacts, see it there? I just fried and melted away. So I might be able to do that. I might be able to get them connected, and with the screws in here, this doesn't move, so they may stay connected fine. But if you forget to unplug it, it's going to get hotter and hotter, and it's going to do this again. Now, it took a long time for it to do this, and apparently at one point, when one of the wires burnt, probably that one that had the big melted contact in it, when that wire let go, what happened was it was making a connection to that. Let me see if I can get the light over here so you can see better. What happened was when it let go, this wire here was moving back and forth. As you'd move the unit or move the cord, it would move back and forth a little bit, and it would make contact across that piece of connector over to this contact, to this terminal. And that's why we were seeing K ohms of resistance. It was actually just touching it. And it would touch it, so it would touch it sort of like that, on and off, on and off, on and off, on and off. Well, that would make it get hotter and hotter and hotter and hotter, which would mess up the control and eventually burn that wire completely off. And that's exactly what happened. So this cord has gotten really hot. It's brittle as can be right here. See? If I bend it, I can't even bend it. It's so hard. It's like a rock because it got so hot there. But the rest of the cord is fine. There's nothing wrong with the cord other than that. That's where it got hot from touching, untouching, touching, untouching. That intermittent connection is what made this end of it. So that's not a big deal. I can cut that off and reconnect if I can get it to connect good enough that I have a 0 ohm connection and not a high ohm resistance connection. But if I do that, like I said, this control got fried. You would have to unplug it to shut it off, or at least unplug it all of the time that it isn't being used. So this is a demo for the customer. If they want me to try to get that control out and maybe fix it, I can try. But if I try and I break it, I'm not going to be responsible for it because I cannot replace it. So it's up to the customer if they want me to risk that. If they don't want me to risk that, and I don't know that I can get that out without breaking it. If they don't want me to risk that, then, you know, that's their decision. And if I did get it out and I did get it cleaned, then the issue is, can I get this connected back to these corroded terminals? I'm hoping I can, but again, there's no guarantee because they got so hot and so burnt. So, I don't know. I mean, there was shipping involved here. There'll be shipping back, and there'll be my labor. So that's a lot to consider. But it's up to the customer, as I said. Thanks for watching the video. If you found it informative, please consider giving it a thumbs up. For the customer, sorry to be giving you such unhappy news, but it is an older unit, and it's lived a good life. You know, if we can find a similar model, you could do a search, like say on eBay, and then save that search. And if you, if one came up that was sold for parts or working but at a reasonable price, might be worth buying it, transferring everything out of this to it, because you know, this part is bad, and you know, going from there. But that's your call. But anyway, I appreciate everybody watching the video, and if it's been informational to you, please consider giving me a thumbs up. I appreciate the support. It helps me keep my channel alive. Thank you.